This video is about equilibrium. Equilibrium is a state of balance between opposing forces. In a chemical reaction, equilibrium is when the forward and reverse reaction are taking place at the same rate. Factors that affect equilibrium are changes in concentrations, changes in temperature, and changes in pressure. In changes in concentration, adding a product always pushes the reversible reaction towards the reactants, and removing a product will always pull the reaction towards the products. In changes for temperature, heating the reaction mixture pushes the equilibrium position to the left, and cooling or removing heat pushes the equilibrium to the right. In changes in pressure, adding pressure increases stress on the reactants, so the shift will be towards the products. And when you reduce pressure, it will create a shift to the reactants or to the left.
Henry Louis Le Chatelier went to the School of Mines in Paris, France. After he graduated, he worked for 2 years as a mining engineer. He wanted to find ways to promote various reactions useful in industrial process, which led to what he is best known for. Le Chatelier's principle states that if stress is applied to a system in dynamic equilibrium, the system changes to relieve the stress. According to Le Chatelier's principle, the addition of chlorine gas will shift the equilibrium to the left to form more phosphorus pentachloride. Let's say there are 2 moles of gaseous product and 1 mole of gaseous reactant. The increase in pressure is relieved if the equilibrium shifts to the left. A decrease in the number of moles of gaseous substances gives a decrease in pressure. Removal of heat causes a shift to the left because the reverse reaction produces heat. Removal of phosphorus trichloride causes a shift to the right to produce more of the substance we just removed.
Instead of using percentage to describe equilibrium, chemists use equilibrium constants. The equilibrium constants compare reactants to products in an equilibrium equation. When there is equilibrium, there is no net charge. Consider the hypothetical reaction in which A mole of reactant A plus B mole of reactant B gives C mole of product C and D mole of product D in this equilibrium equation, so they're balanced out.
Equilibrium constant, or KEQ, is the ratio of product concentration to reactant concentration, with each concentration raised to a power given by their number of moles of that substance in the balanced chemical equation.
So, to describe that in an equation, the equilibrium constant equals the concentration of C to the power of the number of moles times the concentration of D to the power of its number of moles divided by the concentration of A to the power of its moles times the concentration of B to its moles. Equilibrium constants are very important in chemistry. Based on the value of the constant, you can tell what side the reaction is favored when it's at equilibrium. If the constant is greater than 1, then products are being favored in the equation. And if the constant is less than 1, reactants are being favored. And this is a very easy way to tell which one's the important one of the equation.
Finding the equilibrium constant. 1 mole of hydrogen gas and 1 mole of iodine are sealed in a 1 liter flask and allowed to react at 450 degrees Celsius. At equilibrium, 1.56 moles of hydrogen iodide are present. Calculate the equilibrium constant for the reaction. Balanced equation indicates that 1 mole of hydrogen and 1 mole of iodine form 2 moles of hydrogen iodide. To make 1.56 moles of hydrogen iodide, therefore consumes 0.78 moles of hydrogen and 0.78 moles of iodine. First, you calculate how much of the H2 and I2 are left in the flask at equilibrium. 1 mole of hydrogen and 1 mole of iodine equal the 1 mole minus 0.78 moles, which will equal the 0.22 moles. You can substitute these concentrations in the equilibrium for the equilibrium constant. Plug in This is your formula, and you plug in the 1.56 moles on top there and the 0.22 moles for both of these constants. And when you calculate that all out, it equals 50.3, which is 5.0 times 10 to the 1.
We are going to be calculating the equilibrium concentration now of this equation. Bromine chloride decomposes to form chlorine and bromine gas. We are given that our equilibrium constant is 11.1 and we have 4 moles of chlorine gas. And we are solving for bromine gas and bromine chloride. Now, according to the equation, when bromine chloride breaks down, equal moles of chlorine and bromine are formed. Since we have 4 moles of chlorine, we can infer that we will have 4 moles of bromine. We are setting this up and plugging the equilibrium constant in and the given information that we know. So 11.1 equals the 4 moles of the products over the reactant. Now we have to get bromine on one side, so we will divide 16 by 11.1, which gives us 1.44 moles. And we take the square root of both of these because we have 2 moles of bromine chloride, which will give us 1.2. So we now know that we have 4 moles of bromine gas and 1.2 moles of bromine chloride.